Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to find the equation of a parabola in a word problem situation using the geometric definition of a parabola. We've got a couple of examples to work through. This first one says an arch in the shape of a parabola is 20 feet across the base and 12 feet tall at its highest point. So thinking about that kind of shape, here's the ground. I know that it says it's 20 feet across the base, and at its highest point, it's 12 feet. So not to scale. What we've got to do first is we've got to figure out what coordinates are we going to use for the vertex. So a lot of times we'd like to use the origin for the vertex, but if I made, let me just put a different color here. If I made the x and y axes here, now the ground is at negative 12 feet, and that's always a little weird. So I'm going to set up a system here where this is x and this is y. And I'm going to label the points that I know. 20 feet all the way across means 10 feet in each direction. So this point is 10, 0, and this is negative 10, 0. The height is 12 feet, so 0, 12. That's my vertex. And this one opens downward, so I know that the equation is going to look like this. X squared equals 4py. And I can use, I'm sorry, that's not correct. I forgot to account for the vertex. It's 4p times y minus 12. X minus 0, y minus 12. So I know a few points on here. I can plug in, say, this one for x and y, and that's going to help me to figure out what my value of p is. So 10, 0, if I put in the 10 for x, 10 squared equals 4p times 0 minus 12. 0 minus 12 is negative 12 times 4, that's negative 48. I get 100 equals negative 48p. And I can divide both sides by negative 48. And when I simplify the left-hand side, I can divide out a 4 from each of those. I get negative 25 twelfths equals p. Next, we want to write the equation. X squared equals 4 times negative 25 twelfths times y minus 12. Or x squared equals negative 25 thirds times y minus 12. Right? So I've got an equation that models this parabola. Now I can go after answering the question. It says, how wide is the arch 10 feet up? So if we go up to a height of 10 feet, how wide is this parabola? So at that point, I know that y is 10. I can use that to try to figure out what x is, and I'm going to get two values for x, and then I can find their difference to find the width. That's the plan. So I'm going to plug in 10 for y. X squared equals negative 25 thirds times 10 minus 12. That's negative 2 times negative 25 thirds. That's 50 thirds. Taking the square root of both sides, I get x equals plus or minus the square root of 50 over 3. And I can get an exact solution there, right? The width would be 2 times the square root of 50 thirds. I can clean that up a little bit, multiply top and bottom by 3, take what I can out of the radical. Hear me now, believe me later. That would be 10 square root of 6 all over 3. But since I'm just approximating this, I can go to the calculator. What I want to do is I want to find what is the square root of 50 thirds? And the opposite of the square root of 50 thirds. And then I'll subtract those two to get my approximate distance. So over to the scientific calculator, square root 50 divided by 3, I get about 4.1. Let's round to the nearest hundredth, 4.08. So just resketching the graph. It's 4.08 in each direction. The width would be 2 times that, or 8.16 feet. So we can see it was 20 feet wide at the base. As we get it close to the top, it's really come in a bunch, right? Only 8.16 feet. One more. A radio telescope dish has a diameter of 320 feet and a maximum depth of 40 feet. Write an equation that models the cross-section of the dish. So cut it right down the middle. It'll look like a parabola. If the vertex is placed at the origin and the parabola opens up, it says the receiver must be placed at the focus. So what we're really looking for is how high above the vertex is the focus. So we'll get the equation first, then we'll work our way back to the value of P, and that'll tell us how much above the vertex we need to go. So I've got a parabola that looks like this, and the X and Y axes would be here. So my vertex is at 0, 0. I know that this opens upward. I know that these 2 points at the edge of the dish, we're told that they're 320 feet apart from each other, and the depth is 40 feet. So this first point is at 160, 40. And the other is at negative 160, 40. 320 feet across, that's 160 in each direction, and we know the height is 40. And so what we've got to figure out is how high is the focus above 0, and the only way we can get that is with the equation of the parabola. So since it opens upward, I know that it has this format, x squared equals 4py. Its vertex is at the origin, so I don't have to worry about minus h and minus k. I can use this point for x and y in the equation to help me figure out what p is. X is 160, so that's 160 squared equals 4p times 40. These numbers are working out pretty nice because 160 squared is a big number. It's like 25,600. But when we divide by 160, it's going to work out pretty nicely. 160 squared, again, that's 25,600 equals 160p, 4 times 40. And when I divide by 160, that equals 160. So the focus is going to be, not to scale, 160 feet above the vertex of the dish. And again, what I needed to figure that out was if I could find the equation of the parabola, that would tell me P, and P would tell me where the focus was. Now, actually, the equation, I'm supposed to put the 160 back in for P. So the real equation is x squared equals 4 times 160 times y, or x squared equals 640y. But what I really needed was just the value of P. All right, that's it for these two applications. I will see you in the next section where we talk about a shape that we've seen before, but in a different way.